Let us look at proposition number 86 of book 10 of Euclid's Elements. The proposition says to find the second apotome. So in the previous session, we saw how to find a first apotome. Let's begin. Set out a rational straight line A. Let GC be commensurable in length with A, which implies GC is rational. Why? Because A is rational and GC is commensurable with A. So GC is also rational. So basically it means GC square is also rational. Set out two numbers DE and EF such that DF is not a square. Find C such that DE is to DF. DE is to DF. That means a square number is to not a square number is equal to BG square is to GC square, which implies BG square is commensurable with GC square because DE and DF are not relatively square numbers. So DE is a square number, DF is not a square number, but they are commensurable in length. So that means BG square is commensurable with GC square because of this proportionality. Since CG square or GC square is rational, we have already seen this. So is GB square, and GB is rational. So if CG square is rational, GB square is also rational, and which means GB is rational. Now D is to DF is not equal to a number square is to number square. So BG square is to GC square is also not equal to number square is to number square. Again, because of this proportionality. So which means BG is incommensurable in length with GC. BG square is commensurable with GC square. Or in other words, the square on BG is commensurable with square on GC. But BG is incommensurable in length with GC. BG and GC are rational straight lines commensurable in square only. So BG minus GC, which is equal to BC, is an apotome, and which also means that GC is the NX to BC. Now we have to show that it is not only an apotome, but it is a second apotome, BC. So find H such that BG square is greater than GC square by H square. Pretty straightforward. BG square is greater than GC square by H square, which basically means BG square is equal to GC square plus H square. So which means H is equal to square root of BG square minus GC square. And we know DE is to DF equal to BG square is to GC square. So in conversion, we can say DE is to EF is equal to GB square is to H square. Since DE is to EF is equal to number square is to number square, that means BG square is to H square is also equal to number square is to number square. So BG is commensurable in length with H. So we have BG square is greater than GC square by H square, which implies BG square is greater than GC square by a straight line commensurable in length with BG, and GC, the NX, is commensurable with a rational straight line set out. That is the definition of a second apotome. So we can say BC is a second apotome. So that is proposition number 86 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now.